Hey guys, hope you're all doing good and welcome to a new video. Today we will be learning how to model and simulate an entire piston and crank assembly. Basically, we are trying to model a slider crank mechanism, and it's popularly used in a lot of applications to convert translation motion to rotation motion and vice versa. Now there are a lot of engineering applications that use this particular mechanism. For example, IC engines, radial engines, and also reciprocating compressors. The first component is your piston, and the piston is going to be constrained so that it just moves up and down along a particular axis, which is the piston axis. Finally, we have the connecting rod, which basically connects the piston and the crank, right? And because of this connection, the connecting rod is going to have both translation motion and it's also going to be rotating, right? So in this entire assembly, the connecting rod is the one that's going to have the most complex motion. All right, with that I would like to conclude this particular video. In the next video we'll start the modeling process. Thank you. Bye. In this video we are going to get started with piston design. So let's first create a new sketch, right? So let's click on new and then new part, click OK. Then we are going to make sure our unit system is set to millimeters. Now we are going to select the front plane, click on sketch. So we are going to get started with the line tool, click and then drag out the line and then drag it out vertically as shown, and we are going to basically create a profile first and then we are going to rotate it. Now use the 3-point arc, select the first point, the second point, and finally we are going to have another point somewhere here. Now hit escape. Now use the shortcut key S to assign dimensions. Let's select this particular line and type in a value of 101.3 millimeters. And select this line and type in a value of 7.35 millimeters. Select this particular line and type in a value of 6.35 millimeters. And then we'll select this particular line and type in a value of 19 millimeters. And we're going to select both these 2 points and say that the distance between them is 7 millimeters. Next, we need to make sure that this point is 63.5 millimeters away from the origin horizontally. So select these 2 points, drag it out and type in a value of 63.5 and then hit OK. Now we need to set dimensions for the 3-point arc. Let's put in a value of 244.6 millimeters. Now we have fully defined the sketch, so now we can exit the sketch. Now we are going to be revolving this particular profile. Click on revolve and we are going to select the axis of revolution. We are just going to select this particular line, and that's basically the outer shape of our piston. Click OK and you can see that our piston has been created. Now we are going to be creating the slots for the piston rings. So we are going to select the front plane and then we are going to create a new sketch. Use the Ctrl+8 shortcut key to basically align the view. So we are going to be using the rectangle tool and just click and drag it out to create a basic slot. Now let us set up the dimensions for the rectangle, right? So it's going to be 5 mm long and 2.5 mm wide. Use the S key to assign the dimensions. So type in a value of 5 mm for the height of the rectangle and a value of 2.5 mm for the width. Now this particular base is going to be at a distance of 5 mm above the origin. So let's type in a value of 5 mm to position it correctly, the vertical direction. Now we're going to select the end line of the piston and our slot, and we're going to use make collinear so that we align the slot correctly. So now you can see that the groove has been fully defined. Now what we can do is we can use the revolve cut option to basically create the slots. We need an axis for doing this. So let's create a vertical line which will be used as an axis of rotation for the cut operation. Hit escape. Now this line is only for construction purposes, right? So we need to right click and then we need to click on construction geometry, right? And let's exit the sketch. Now let's go to revolved cut, click on it, and you can see that all the selections have been made automatically. basically the axis of revolution and the profile that is going to be cut out have been selected. Now we need more slots, so we don't have to go through the process of sketching again. We can just use the linear pattern option, and we are going to select the extruded cut, and we are going to make sure that along the Y direction we make multiple copies of this extruded cut. We are going to be using the top plane to achieve this, because the top plane has a normal along the Y axis. Now you can see that it has created a few slots, but this is in the incorrect direction, so let's reverse the direction first. And now you can see that the slots appear in the right position. Now we need to type in a value of 10 mm, but that's the value that's already there, so we don't have to change it. And we have 3 instances, and let's just click on OK to create our slots. Right, the final thing that we need to do is create a hole through the piston so that we can insert the wrist pin. So let's go back to front plane and click on new sketch, and we are just going to draw a circle. Right, so let's use the circle tool. Let's click and drag it out, and then we are going to hit escape. So we are going to use the shortcut key S to assign the diameter of the circle as 25.4 millimeters. We are going to select the center of the circle and the origin and type in a value of 40 millimeters, which is the vertical distance. Now you can see that the circle is kind of moving radially, right? So we need to constrain that. So we are going to select the center point and the origin and hit make vertical. So now our sketch is fully defined. Now let's exit sketch. Now we are ready to make the cut. So let's select the extrude cut option, and you can see that our circle has already been selected. By default it's using the blind option, which is going to cut only in one direction. We can use the mid-plane option to basically cut on the both sides. Now since we know the exact dimension, we know that the radius is 63.5 mm for the piston, right? So we can just multiply this guy by 2 so that we can cut it from left to right completely. The other option is through all and both sides, right? So this means it's going to cut all the way on both the sides so that you don't have to provide any value. This is going to be quite convenient, and you can see that in this case we have created the cut perfectly. Now we are going to go to the right plane now, and we are going to create a new sketch and use Ctrl 8 to look at it in the right direction. We will be using a 3-point arc now, and let's just click it here, here, and finally here. We are basically trying to provide a shape for the bottom of the piston. Now we are going to provide a dimension for this arc, so let's select this particular point and this particular origin and type in a value of 42, right? Then we are going to select the arc and provide in a value of 45 mm for the radius. Then we are going to select this point and this point, and we are going to click on make horizontal. And finally we are going to select the center of the arc and the origin and hit make vertical. This is going to fully constrain our sketch. Now we can exit the sketch. Now we are going to select the shape and we are going to make an extruded cut. So let's click on that, and we want to basically cut on both sides, so we can just use through all both, and that's just going to cut on both the sides. While using this cut option you need to be a bit careful, because you see that the flip side direction is selected to outside. This means anything that's actually outside of the profile that we selected has been cut out. Now we kind of want the opposite, right? So what we are going to do is we are just going to click on flip side to cut, right? So this way anything inside our profile is going to get cut. So now if we hit OK, you can see that the cut looks like what we want. Now these sharp corners needs to be rounded, so let's use the fillet tool, and we are going to be selecting this particular edge and this particular edge and this one and also this one, and let's just click OK. We are going to leave we are going to fillet it at the default radius. Now for the gut joint pin or the wrist pin, we already have a groove, but we need a mount, right? So when the wrist pin is actually placed, it needs to basically be sit somewhere, and that's the mount. So we're going to go back to the front plane, and what we're going to do is we're going to select this particular circle, and we're going to click on convert entities. This is going to create a circular sketch in our front plane. Now we are going to offset this particular circle at a distance of 2.5 millimeters. So let's just click on the circle and type in a value of 2.5. So this is just going to create another circle, and then let's click OK. Then we are going to exit the sketch. So now we are going to extrude this particular shape. So let's click on extrude, and you can see that it's starting the extrusion from our circle. So let's use the offset option so that the extrusion starts at a distance of 30 millimeters from our original profile, right? So you can see that that's where the extrusion starts from, right? And then we want to make sure that the extrusion takes place up to a selected surface, which is nothing but the inner face of the piston, right? So what we're going to do is we're going to just select the outer surface, sorry, not the inner surface, the outer surface, and you can see that this produces the result, but it's kind of in the opposite direction. So click on flip, and now if you actually hit OK, and if you take a look at the mount, it looks perfect. Now we need the mount on the other side as well, and it makes a lot of sense to just mirror this. So let's go to the mirror tool, and we are just going to select our front plane, and about the front plane, this particular feature is going to be mirrored, right? And you can see that the right feature has been selected. Just click OK, and you should see a copy of the mount on the other side. Alright, that completes the modeling process of the piston. Go ahead and save the particular model, and I'll see you guys in the next video. Thank you. Bye.